Okay. We are back at trying to figure out what's going on here. And as is usual with these sessions, kind of have to mentally backtrack a little bit and remember where we were, right? So I was, I think, a bit stuck with understanding sort of kind of like noticing that these doesn't seem to be, I just don't see how is that a real sort of how that relates to how that relates to the loss function. Exactly, the loss function is defined, which probably doesn't make sense, but the loss function is defined in the main file, I believe. No, it's it's in encoding. No, it's in training. So it's defined in here. So we've got the loss function. We were working with these, right? So, but the idea first was to work. So this is what I was doing before, right? That I said, well, this makes no sense to me. That we're ignoring the. Oh yeah, but that was kind of like, sorry, I'm just kind of like backtracking live as I'm thinking through these. So this was the first. I thought maybe it makes sense because really in our training set, we kind of just have perfect in the training in the examples that we have like a perfect prediction. But the ground truth is it's not really a distribution, it's like a one, like that is the word that was supposed to be, you know what I mean? Which I think then the categorical cross entropy loss, maybe actually it's more of an overkill than I thought, because this is basically just say how close was I to that prediction. Well, not that, right? But basically just saying, well, yeah, basically just looking at what was the probability. I almost think that I'm going to get rid of that again. Like I put that at 1 or 2 videos ago, but I think it just makes no sense. Essentially, I was here, and I think that makes actually sense. Yes, that is in a way it tells you the true index and what was predicted, right? And then the negative logarithm makes sense because if the prediction was 1, then you're going to get a 0. And if the prediction is 0, which is kind of not undefined, it's just, it goes like these. Right. Maybe, yeah, but you know what I mean? It's like isn't that value then just a north of a derivative? And maybe that is why the subtraction makes sense. I don't know if I had plot the ghostwriter plot negative logarithm. So this is indeed, by the way, one of the good use cases of such. You still can get the wrong thing, but it gives you a good basis for this kind of quick tests. If I do show that, yeah, it's going to show that. Okay, cool. Maybe I should just merge these two things. Yeah, exactly. So that's negative logarithm. This means that if let's say x is like, so what are we doing? Because we're looking at and saying what is the probability of the true index, but in our prediction distribution. If this is 1, then the negative logarithm gives me like 0, right? Or close to 0. So which is good. This means I don't have to do anything. But if it says if it says that it's that it's 0, then it will give me like a maximum, like we're close to 0, then it means then it will give me like a very high number. So and can we plot now and now add the plot of the derivative of negative log using another color. Okay. Work. Because essentially what you want to do is you want to use the derivative. That's a bit stupid. But yeah, that's kind of, it's -1 divided by x. What does it mean though? Because essentially what we're doing here is taking the logits. No, we shouldn't take the logits, we should really take the probabilities. We take the probabilities, we minus it, we minus that thing. Yeah, that's also a bit odd though. That's also a bit odd because okay, I think that the minus makes sense, as in it's a good approximate. The derivative is kind of going to tell you the same, because the derivative of the function is basically let's say if I am at if x is 1, this means that I nailed it. The derivative is going to be almost 0. Almost like I want to plot the derivative, right? Don't want to plot. Let's just plot the derivative. So let's just not plot y. Let's just plot the derivative. Oh, stupid. Thanks. Let's just plot the derivative. Yeah. I think it makes sense, just as in clear. If I go close to 1, the derivative is going to be 0. This means you shouldn't really do almost anything. And to be honest, it almost feels like it's actually not good at all, because, well, if it's something like 0, then it's like -100. So it's like do a lot. Whatever that is, right? But at some point, it's funny because at some point, if x is 0 point something, it's like, it's just a funny derivative. I don't feel like that actually makes a lot of sense, though. I don't know why this is something that is easy to choose, or that is a good choice. Why the logarithm makes sense at all? Why not? Why? Like, why is that good? But that's maybe another question. If I plot the negative logarithm, then know what I mean? because in the training, if I'm looking at the difference, the still, what does this still tell me? Train. Can I not train, but no work. What is these? So what is these doing? Let's maybe focus on that, right? So we've got something that it's let's just assume that it makes sense. You're calculating how far off are you from the ideal probability. Like, I don't know, is that a good loss function? Maybe let's try to understand. Let's try to understand what is it that this is doing. So can you explain me this, bro? So it's calculating, it's taking A1, it's reshaping A1, and it seems like it's trying to transpose it, right? Let's remember what A1 was. A1 is after the activation, after this kind of activation function, right? Which is essentially what we're using. It's what we're using to calculate the last. So there is basically a Z1 and a Z2, like there's two steps, right? Exactly. This is the first layer and this is the second layer, because the second layer is with W2. Yeah, W1 is basically the input and the hidden size, and then W2 is the hidden size and the output, right? So, but then the first is calculated. So the second one is calculated with A1. That also doesn't make much sense. That the derivative of W2. Well, yeah, no, it does make sense. Okay, it's based off of A1. So you take A1, you take A1, transpose it, you take here. You're also doing you're also transposing these, aren't you? Can we try to pretty print or print the shapes of these? So can we try to basically just say, first of all, can you explain what these explain? Can you explain what these two lines actually do? This is essentially the two it's just reshaping it so you can do the dot product, right? So this is shaping it from shape A1, shape 1. Oh, okay, from shape 2 like this 1, two-dimensional array. It's to a two-dimensional column vector. Column, and then row, right? Yeah. Can we print these? Print A1T. Can you just print, for example, so code pretty print NP array values? You know what I mean? Like just like just pretty print T, and then pretty print DZ2, exactly. Okay. This is for these I gotta do just the train stuff, right? So Python train.py. That should do it, right? This as function. It's also what the okay. Give me a second. Let's stop that. Okay, so we've got a very nice column vector. What the first is A1. Why is it all ones though? This is very odd. Very odd, but it's maybe because of these, I don't know, but it's all ones and minus ones. It's a huge column vector. And then you get something that is one and the shape of the vocabulary, but it's almost all zero. No, wait. Not the shape of the vocabulary. Actually, this is DZ2, right? Which is obviously almost all zeros. So, and this is the row, right? And then we do the dot product. Like if it's all like you've got a bunch of ones like these, right? One, whatever, minus one, whatever it is. And then you've got like something that is like mostly 0, 0, 0, 0, 0, 0, 0, 0, because and it's gonna have somewhere minus one, right? And then essentially what we're doing is, so when we're doing the dot product, we're doing the dot product. We're doing the dot product, and then the dimensionality of dot product if you know m is m is length of call vector, and n is a scalar. That would make any sense, though. Make any sense, though. Make any sense, though. So shape 128, 1. Pretty odd that it's all ones. And then okay, but this nothing happened here or what? Yeah, well, the second, I mean, no, why? Uh, changes progress. What? Print DW2. Just so I can see these, yeah. But you're essentially what I find odd is that you're multiplying blah 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 blah. Cancel. Okay. No. Let's take the latest example. So we've got these array, which is all one, this column, which is all ones. Oh, they stopped it, the previous one. A column that is all ones, then a row, and then, oh yeah, okay, and then DW2, which has got these dimension. 28, 128, 28 by, yeah, which is the shape. Which is the shape of W2 as well, right? It's my guess. But essentially, this is mostly like all freaking zeros. It's and why is that? That is because with sum tab dz2 with sum tab dz2, like the dot product of these, which is whatever is in here, right? Is there any, what's the biggest value of these, of dw2? The biggest, so compute the biggest value of dw2. So compute, so print mean, max, and average value. Two. Okay. Just that would just be, that would just have been enough. I just want these, and then we'll get to the output again. So, okay. So they're all very small. They're all very small. The minimum, the maximum value. They're all very small. It's a lot of zeros. Let's put it this way. It's a lot of zeros. Doesn't matter. That's a lot of zeros. That's a lot of zeros. That's also a lot of zeros. Effectively, but maybe that is because of these as well. Why? Why are we multiplying by 1 divided by m, which is, what is m? What is 1 divided by m? Print 1 divided by m print 1 divided by m. So it's a very small number. Like, you know, whatever it is, like if I don't do that, okay, if I don't do this, then what happens? Is this kind of better? So you've got all the ones and stuff. Then you've got the dw2, 1 divided by m, that's fine. Mean value of dw2 is -1. What is that? Like, why is that 0, 0? Yeah, 0. Okay, so it's kind of like a 0, but there's like a -1 somewhere, and there's a +1 somewhere. Right? Okay, but I mean that doesn't change, right? So if I do these here, it's still, well, no, because there is a sum, right? No, divided 2 learning, right? Okay, it's fine. It's fine. Why do we multiply? Why do we multiply during the back propagation? That's a great change the number of training samples in the data set. To normalize it with respect of the training examples in the data set, but that is also wrong. Training examples is not that m. We average the gradient across the data set. This doesn't prevent the gradients from becoming too large or too small, which can include. I think m should be like, this is not supposed to be. This is not, because the problem is, because I'm not doing the batch thing. That's the problem, is because I've gone a bit away from the traditional batching stuff. You know what I mean? I think this is just what it's trying to do is it's trying to take the number of tests, but it's not really helping because it's taking the vocabulary size. You know, that is kind of the problem. So this should be this basically should be. I think I understand what it tries to do to sort of normalize it across the. I mean, I still not so sure if that is actually needed or not. So let's just comment. I think should be maybe uh the training or I think it should be the batch size. You know what I mean? I think it should be batch size. I think that's what it is. It should be the batch size because if you're taking if you're essentially taking bigger batches later on, you want to normalize that, by the batch size because you want a bigger batch size to be obviously equally representative and not to bias that. But as we're not using these, then maybe that should just stay this way. And if I just let it run like this, and I'll leave all the prints and shit and stuff and whatnot, but I'll just say train do epochs, one epoch learning grade 0.01. No, let's see. Okay. But maybe I should actually switch off all these print statements because I want to see no, does anyone know what a better way to print the whole thing? Anyway, I'm gonna uncomment all that stuff and then just let it run. See if things look better now. Although still I haven't really done anything, but I mean, other than correcting that, obviously, because that's definitely the wrong thing to do. But we know that what it's doing is it's taking, let's see, loss 68, 56. Like I want to see that at least that kind of doesn't have huge spikes or whatever, but it actually consistently goes down. Which it kind of seems that it's doing a little bit. Let's see. Goes down, a little bit up, a little bit down again. Let's see. Let's see at the end of the training run. But you know what I mean? Like I think this is like the problem is this was not doing anything at all. Like this was not doing anything at all. It's not really gonna look like I like it anyway. Ooh, up again to 64. You know what I mean? Like it was just not acting. Like it was literally not making any change because of these M being like super high, close to zero, and so everything was kind of like zero. Obviously, and in hindsight, I think I should have spotted that earlier on. But okay, let's think about this. So the how is this really being? On one side, I have I have these activation things. Then I have the reshape stuff. So it's essentially doing these times these times these. It's essentially getting into an array where, but it's still, I don't think it still makes sense. I still don't think it makes a lot of sense because I still think that it's essentially too harsh because if we're multiplying it with these, there's just going to be a lot of zeros, and the dot product is just gonna, you know what I mean, kind of kill these things. Kill what though? Kill what though? It's gonna do. It's gonna be super smooth. Goes up and down again. It's actually plotting it at the end. Is it actually plotting it? Oh yeah, it's plotting the loss. Oh, I think it's done actually, but it hasn't opened the. looks good here, but then it's like, blah, nah. It's still gotten lower, but it's definitely not. This is not how you want it to look like. Definitely not. And 56, and it started all the way up to like 68. So you know what I mean? How much time left? Probably nothing. Yeah. Anyway, at least I figure out one mistake for sure. I think that makes no sense at all. This M thing should be something else. But when you do batches later, but it's not for now. But then this is what I'm still not happy with, which is that it's essentially doing a dot product between A1 transpose and DZ2. DZ2 is just essentially a lot of zeros in 1, 1. And so if you do the dot product between these, then you're just going to get a lot of zeros and something, right? Okay, yeah, sure, fine. Maybe it's not that stupid because then you just have something that's got a lot of zeros and then a minus somewhere, right? Because it's gonna have a -1. That's okay. So it's just gonna filter out these things, and then this DW2 and this DW2 what's then gonna do? What is then gonna do? DW2 multiply by the learning rate and minus it to W2. From that perspective, maybe that is not that bad because can I print the difference between two print? What happens if I print self W2 minus W? Like what happens if I print this? I'll leave it here. Okay, I just want to see what is that difference. Readable or not readable? So it's doing, okay. Maybe the other way around. So maybe print max of DW2 I'm stupid, I already have it there. NP max, yeah, okay. Let's leave it here. Shell. Okay, the biggest is 1 though. Okay, but that's not bad. That's not bad. The biggest is 1. So this means there's always some kind of change happening. There's always some kind of change happening somewhere. There's some kind of change happening somewhere because there's a 1. And this 1 is going to get reflected then into like this minus here, right? So it's going to be somewhere there's going to be a number 1 that is minused. And so it's going to change, not one, but like times the learning rate, but it's going to change something at least. So, okay. Not bad. But still something's here off. Something still here off, obviously. It's going to change for sure something. But is that, how are we guaranteeing that this is being changed, whatever it needs to be? Yeah, well, you're guaranteeing it because essentially by doing these, you kind of you carry the whole vocabulary size. And so you know exactly the one that, it should be the other way around. Maybe it should be, shouldn't it just be, shouldn't it be like the, shouldn't it be that it's true minus prediction, right? So then you're adding one. No, that makes sense. And you're adding one because it's minus minus one. So that what? So that so is that the effect that it has? Can we try this out? Can we try this out? What should I do to try this out? I should take a look at, I should reduce the, I should do a small test and I should basically, let's say I have a vocabulary, let's say I have a vocabulary, so it's going to be like another test, like I have a you know what I mean? Like I have a vocabulary of like 5 words. Um, I want to see this working. I want to see this working out. I have a vocabulary of like 5 words or so, and then you know what I mean. And then I want to see if this, if I can get that to work well. So if I can get that to work well, this prediction, this is true. This true kind of came from, you know, like true, like not true, sorry. The prediction was okay, no, maybe not, actually. You know what I mean? Like the predicted kind of came out of doing some sort of like some sort of like function, right? Let's call it A. A times something, didn't it? It came from doing something like these, which is basically in the network here, right? It came from doing these. A, whatever this activation is, in W2 logics, right? So it came from like, exactly, it came from something like where are nodes? It came from something like A times W2. That's where the prediction came, right? And so that kind of was giving it was giving you something like, yeah, whatever, this kind of like let's say this is just like that, right? And obviously the true thing is essentially, let's say the true is like 0, 1, 0, 0, 0. Using the probabilities, yeah. And so if I do t minus p, right? So if I do this minus these, then I'm going to get basically something that just you know, p minus d, something that just looks like not true minus b. But if I then take these, multiply it by a, that's what this thing is doing. It's multiplying these by this a1, right? Multiplying it by a1 transposed. Maybe that's a mistake. There should be w to transpose. I don't think this makes sense. This makes no sense at all. Well, it is somehow here it's doing the multiplication of w2 and dz2. And I should probably, okay, check for this. And then a, so I take that, I multiply by a, you know what I mean? Because essentially this is, if this is like that, this means it's the same. It's like row and column is the whole row is the whole column. No, it's column and row. So it's these times these. So essentially, it's kind of like, you know, like a1 times, you know, a1 times w21, etc., right? So what will happen is if I multiply these by a1, then these a1s will kind of become like all zeros, right? With the exception of the places where there's a 1. So in this place where there's a 1, this is going to stay there. And so you're only going to keep the components of W2. No, yeah. No, you're only going to keep the components of A1 that really contributed, because if we do this and basically do this times A1, you're only going to keep the components of A1 that contributed to the correct thing in here. But then I'm just not so sure why we're doing why we're not touching A1 at all either. Because this is gonna basically, I gotta go, man. This is gonna basically just be, it's just gonna keep the components of A1 that make sense and then code them as changes to W2, which is these. No, to W2. Changes to W2, but A1, the A1 activation stuff stays the same. Changes to W2. Which obviously have an impact on the next prediction. But is it going to have the right impact? For sure it's going to have the right impact, as in like it's going to have the impact on the places where it matters, right? Or where you want it to matter, because these are the things that you want to keep. In theory, that should without actually making a formal proof, like I think that makes sense, right? Because you're capturing the difference, so you're capturing the places where you want to change stuff. And if the true is 1 and this was 0, then we want to do a change there, but then we make it like I don't know why it's A1 involved here at all, man. Keeping the components of A1. Why are we doing A1? Why are we doing A1 at all? Why aren't we just multiplying it by? Why are we involving A1 at all? Question. Oh. Question. Why are we involving A1 at all? You might as well just involve why don't we just do dot with W2? You know what I mean? A1 is not being modified anywhere. Here it's just added like that. Which is anyway based on fucking W1. Okay, but then used to build AW2, but we're not modifying. That is what I don't understand. That is what I don't understand. Material for the next session.